Okay, I think we can get started now. Welcome everyone to our webinar on identifying risks. We're going to cover a bit of BOF, a bit of Cabal Strike on this one, and also a bit of tradecraft as it comes to identifying risks when you're doing attack emulation. My name is Carlos Perez. I am going to be one of your hosts today. Today with me is also Chris Paschen, one of our researchers here at TrustedSec. So a bit about TrustedSec itself. We were founded in 2012 by David Kennedy. We are a full service consultancy. So we cover almost the entire gamut of services that you may need for cybersecurity. And our main goal here is to actually help our customers defend against all kinds of threats in this environment of cybersecurity, which is constantly changing, constantly evolving, new techniques, new TTPs, new ways of people, kind of rehashing some of the old and with some of the new stuff that actually changes in the industry itself. So we like to provide that kind of services to our customers to make sure that they're up to date with all of this stuff. So some of the services that we actually offer, we offer incident response and forensics, which has been very popular lately, thanks to Microsoft Exchange, and also thanks to the uptake in ransomware. We have been helping many customers deal with this. And then after our incident response and forensics team has been able to identify, mitigate, control, isolate, and do all kinds of things against threat actors. We have our remediation and assistance area where we actually help our customers then how to set up their environments better, how to secure them, how to automate some of their tasks with our remediation team. We also provide training for our customers to help them skill up in their environment. And that is in addition to all of our security testing and analysis that we do in doing attack emulation, both doing red team engagements and doing penetration tests, vulnerability assessment. And in addition to that, given that security is part of a business process and is more of a byproduct of human interaction, we are also providing consulting in program assessment and compliance, and also helping you with your security program management. And as always, our approach is a holistic approach in improving your security. It's a bit of a repeat, so I won't go through it, and I'll just keep going here. All of our engagements are led by senior level consultants. In fact, I invite you to go into our blog and read the blog post that we're providing out there with information, in addition to our YouTube channel for TrustedSec and our GitHub. And you're going to find the quality of the material that we put out there to help not only our customers, but also help our industry, given to you by these industry leaders and creators that we have in the company, is going to be of great value to you. In addition to that, we have a dedicated attack research team, which I'm the lead for, and Chris is one of our researchers. We are part of the team that looks at developing the multiple frameworks that we use internally, in addition to multiple tools that our staff uses in their engagements. So, identifying risk. We have been covering some of the tradecraft that you need to do when you're working and doing attack emulation. In the last webcast that we did, we talked about identifying why is it important for you to actually leverage BOFs inside of Cabal Strike. Some of the advantages, disadvantages, how do they work, how do you load them? For example, we don't have callbacks for them, which is a bit annoying when we want to automate some tasks. but the ability to be able to run in process and not create another process is of great value to us in terms of not giving the defenders a way to detect the actions that are being taken, like real attackers do with their frameworks. So defenders, since they own the battle space, they have two key operational influences upon us. One of them is tools, because the environment itself, the controls that are in place in that system, are going to dictate what tools are we going to use. That's why we spent in the research team quite a bit of time uh, prepping tools for our different payloads for that initial access, because there's going to be some EDRs that are going to detect one thing, and probably they'll miss others, but the AV will catch that, and we need to constantly be researching, looking at the different tool sets, identifying which EDR detects what are their capabilities, in addition to Windows operating system controls, how can they impact the actions that we take. We document all of that and take it into consideration into the information that we provide to teams, in addition to the tools that we write. So all of that stuff that a defender sets in their environment and how they configure it, it is not only good to have a blinky box that the marketing department of that company says, this will block anything. This is a anti-advanced adversary tool. If the person doesn't have the training, doesn't know how to configure it, doesn't do much outside of the defaults. But the defender, if they have the training, if they have the tools, they're going to force us to modify what we have. They're going to force us to, or in other words, they're going to raise our cost in terms of tooling. And because of that, they're also going to affect our tempo. How fast do we move in that environment? Because we are going to have to modify our TTPs. We're going to have to test. We're going to have to validate. There's going to be stuff that we like, which we're not going to be able to perform. For example, all of a sudden we land in an environment and we start doing our initial recon, and we see that the company has been doing presentations with Microsoft, with webinars, or have gone to other security events, and some of their presentations have been like, hey, we use Azure ATP to monitor all of these kinds of Active Directory attacks. What does it happen? All of a sudden, Kerber roasting may be out of the our tool set. That means that something that actually gives many attackers initial access is no longer there. Now we have to use other techniques of credential harvesting, validation. We have to be very, very careful with our enumeration. We have to be even more careful. How do we spray and test those credentials? So all of a sudden our tempo has been affected. So identifying all of the different controls are in the system and applications are going to affect these two areas, which are very important for us. So typically what we do is we like to use the KISS principle. We keep it simple, stupid. In other words, we try to stay with APIs as much as possible for those initial steps until we actually validate what we can do, we cannot do. Right now, there have been many advances in tooling with Active Directory, with many advances in EDRs, advances in antivirus products, advances in the operating system itself, at what controls do they provide. And we have to be very careful with what we do. I remember a couple of years ago with the initial release of Windows 10, Windows 8, PowerShell was awesome. We could do a lot of stuff with PowerShell and no logs were being generated outside of a run space actually coming up or down. But we cannot do that anymore. Right now, PowerShell has a list of what they call bad words, which is stuff that they'll detect somebody trying to bypass AMSI without obfuscation. So all of a sudden, now we have to obfuscate our PowerShell code. And we shifted to .NET. And all of a sudden, AMSI for .NET came in. which looks at strings that come into the load library call. So now we need to obfuscate .NET binaries to bypass that. Again, more cost, more retooling. And then other solutions have known that with obfuscation, they can detect that obfuscation itself. Like, hey, we're seeing that this code, the pattern of characters that we see, this is obfuscated, and they'll flag it, and they'll probably send it to a analyst to inspect and report back on it. Also, we've seen advances in MC when it comes to Office applications. All of a sudden now VBA, even if we obfuscate our code, it's Microsoft learned their lesson from PowerShell and how easy it could be to bypass MC, and they applied that to their VBA MC engine. And now what they're getting is the calls themselves and what parameter was passed to those calls as they saw it. So even if we obfuscate, they're looking at that code unobfuscated, and they're getting the raw bytecode that is actually being executed to examine. There have been advances in ETW. Execute assembly is one of the things that get detected the most, and it's very easy to detect because they're going to use either ETW or they're going to use kernel callbacks, and they're going to be looking for CLR.dll, CLR.jit, MSQuery.dll to be loaded, because they have to be loaded, and the way that they get loaded, there's no way of obfuscating or hiding those DLLs when we use execute assembly. So it's a very easy way to detect if somebody is trying to use .NET in an unmanaged process, which means that we now need to have a list of processes that normally load .NET, and we have to rely on those. So we still depend on proper enumeration of the environment, knowing what controls are in place, and all of that kind of stuff. That's why we need to understand the frameworks that we're using. At TrustedSec, even though we're talking about BOFs right now for Cobalt Strike, we also have developed our own internal frameworks. And we have taken some of the lessons learned from Cobalt Strike and applied those lessons into our own frameworks. One of the things that we talk with our operators is to make sure that they understand what actions are being taken in the background. That's why we focus a lot on sticking with APIs and not so much with command line tools. Let's say that all of a sudden you switch to Metasploit, and you can still use Metasploit in a pen test, and it works if you take the due diligence to obfuscate your code and make sure that it's not working with a solution that actually scans memory, and it works very well. But when you look at what they call the mixins for post-exploitation, a lot of that stuff's actually running command line tools, which is very easy to track. Some of them are even running WMIC, which would be a WMI command line tool, which will actually kind of raise red flags in an environment where the defender's material level is pretty high. So typically we want to gather as much information as possible, and we want to make sure that we're actually correlating that information and that we're sticking with APIs. So a very good example of this is a script by Direct Express. He has a red team script for enumeration, which I like. It leverages the Cobalt Strike BRED query value, and BLS to gather a ton of information that is going to be useful for us when we're using Cobalt Strike. So if all of a sudden I go here and let me bring up this a bit. So when we go here into code, one of the things that we see is that he's gathering files that are on the system, documents, desktop. We're collecting all of that information. We're getting what are the .NET CLR versions, because we know that AMSI was added in version 4.6. So we are already identifying potential controls. We're identifying map drives where we can get information. We're getting exactly what is the version of the OS. Different versions of Windows 10 have different controls. In fact, it can even impact command line tools. For example, now with COVID times, many people are running machines not connected to AD because they're working from home and they need a machine fast to get somebody up and running. One of the things that we may see is a home version of Windows 10, and all of a sudden the scheduled task command line tool is not going to be there present. Right. Let me make sure that I'm sharing my screen. Oops.
I cannot believe you are.
Yeah, lost the screen. Can you see it now?
Yes. Now it
okay.
came through.
Sorry about that. So here's the CNA script. We're using BLS to get information. We're looking at the registry to pull data. So the registry commands are very powerful because Windows depends on the registry a lot. So here's the entries where we're getting the exact information, the BIOS. Some organizations are actually moving to VDI as part of their service. So with the BIOS information, we're able to identify probably if somebody is running a virtual machine. We can get system policies that have been applied to the system. We can get the version of PowerShell. We can check if PowerShell login is in there. We can get the installed software. Sometimes we may rely on processes, but there are out there defensive solutions which actually start up other processes that look like legit security products and just suspend them just to trick attackers into not executing automatic code. And that may also trip us as we're performing actions. So that data correlation becomes even more important. We check installed services, which we then compare to installed software to make sure that somebody is not in that box who shouldn't be with a fake service. Environmental variables, we get Internet Explorer firewall policies, settings for LSA that may control how we get those credentials. And as you can see, everything here, we're doing it with API calls, which are specifically not executing any other command, because probably there are going to be some calls inside of Cabal Strike that actually just execute PowerShell in the background, or they execute a command line tool in the background, and that may get us caught. So we have to be very, very careful with what we select. And that is a very good example of a very good script that actually covers a lot. The other one is we check advanced audit settings. A lot of people don't know that your advanced audit settings, when they get pushed to a system, they're readable to everyone. Everyone can actually read those audit settings, and they're stored even in CSV files, which means that you can pull those back. And in fact, one of the things that we did with our internal frameworks is that we provide what we called recommendations to our operators, where we pull all of these audit settings, we deduplicate those settings, and then we kind of like give them warnings like, hey, they have process auditing. Be careful when you do this. Hey, they have kernel object access. Be careful because if you touch else has, this may get logged. Hey, they have the settings in place for auditing registry and for auditing modification to files. So you need to check certain registry keys to make sure before you touch them that there's no audit policy setting that may get you detected. For example, we love abusing services, but let's be honest, the audit settings for services, if you're not using the Service Control Manager API and you go straight to the registry, it sucks. It won't detect you creating a new service or modifying the service. So every attacker out there simply goes directly into the registry. So just simply enabling auditing on that registry key pays a lot of dividends. That's why we check if they're actually doing this kind of stuff. And in my experience, sadly, a lot of organizations actually are not implementing properly advanced audit settings. You can ask our incident response team. They would love it if rolling into an incident and finding out that a proper audit setting has been deployed into an environment. But again, professionals are predictable, but the world's full of amateurs. when a professional is going to set that. And since we're professionals, we always, at the initial stage, we always check this. We don't assume, because assumption is one of the biggest mistakes you can actually make. And we have a lot of repeat customers which actually have learned or have gone through multiple purple team engagements with us, and they have a very tight ship. So it is part of our SOP to actually check for this. So one of the BOFs that we actually created, which is one of the initial ones that we recommend, which actually provides great value, is one for checking drivers. I like it because it actually checks the signing of those drivers. We've actually seen people rename some drivers, or some products are adopting this. One great example of that is Sysmon. Sysmon allows you to actually rename your driver and also rename the service to hide itself. So with solutions like this, we can actually just simply find them by checking the code signing, because hey, Microsoft requires that your drivers be signed. That's part of the process. And I cannot go in as TrustedSec and buy a code signing certificate for a driver with all of the extensions and say, no, don't put TrustedSec. Put global mantex chipping. The CA will not accept that. So they cannot hide the way that they sign stuff. So I'm going to leave you with my good friend and colleague, Chris, to demo that for you.
All right. Yep. As soon as you, thank you. We'll go ahead and get this popped. So that particular BOF is really simple to run. It doesn't take any arguments. When you run it, it goes through, enumerates the registry and looks for, or actually it's just enumerating for .sys files. And it will call out specific known AV or EDR vendors. Now for this one specifically, if you want it to extend this and you downloaded that code, the list of what it's actually comparing to is here, because it doesn't have the knowledge in its backend to be able to just magically know, this is an AV or an EDR vendor. So as those things continue to expand, you could add to that list and just want to call out this code was adopted from other open source research.
Now, I know that there are other ways for checking for drivers. For example, one of them that I've seen people use is that they keep a list of the .sys files and compare that. But vendors do update, vendors do change. And also BOF is kind of limited in some of the stuff that we can do in terms of its stack is very small. So doing stuff like a lot of recursion and keeping a lot of stuff in memory that you're trying to track becomes difficult. So we try to keep it as low as possible in terms of its actions for stuff that we can do. Also, we don't want to provide way too many strings for somebody examining. Actually, Defender and Defender ATP are a product from Microsoft that actually, if it looks in memory and finds a list of security product drivers, it has a unique signature for that. Same if it sees that in an HTA file or a VBA file, for example. That's why we kind of went with the signatures, which is actually a bit safer. Now, another thing that we like to do is to check our current process. Once we get a bit of information, now we're going to be performing additional actions. One of them is just to check our own process to see, hey, has there been any third-party DLL from an EDR or AV product loaded here? And also another one that is becoming popular as part of our tradecraft is to actually also check for cohabitation. Is there somebody else in this box? Chances are that you may land in a box and somebody may be there in that box. So checking those DLLs and making sure that you don't see anything weird, it's should be part of your process?
Yeah, so for this one, specifically, we'll talk about listing off processes in a second here, but we're looking at this list mods, which should probably have its help expanded at some point. But what this allows us to do is look at all of those different pieces that are loaded into a process. So if I was just to call off Explorer here, we can see all of the different DLLs that have been loaded into this. So if an EDR AV solution was hooking this, we might see their DLL that they're mapping code through in here. Something else worth looking for, if I can pull it off here, is for whatever reason, in Microsoft's infinite wisdom, they've started loading some DLLs out of app data. This is a user writable path, as opposed to something like System32 or program files. So as far as persistence, looking for user writable paths and things that you know will be frequently loaded on a box, and then seeing if you could shim your way in between that, is something else that this BOF can also be used for.
Now, the other thing that we can do is check for processes. Just a simple process list provides a ton of value. Now, the Cabal Strike default ls command doesn't provide you command line, and command line actually does provide even more value to understand several aspects of that process that is running. We can gain information like purpose. What is the purpose of the host that we're operating in? We can also gain information around what are the different security products that are in that system that may impact us. Operational reference, because one of the things that we're starting to see is that EDRs and AV products are actually keeping a list of parent-child relationships of what they consider normal as part of their ML process when the machine's connected to the cloud. So that comes into play for us for when we want to spawn another process to inject into, that it looks and behaves not only with that parent and child relationship, but also with the command line, that it behaves like something normal in that system. So all of a sudden now we have operational reference. And again, cohabitation, hey, is there any process here that looks suspicious?
Yeah, so if you're used to Cobalt Strike, you are likely used to the PS command, which will give you your parent-child relationships via the PID and PPID and the user executing. Now, with our task list BOF, you can execute that locally to get the command lines, as Carlos was mentioning, which you might be able to pull off some interesting information using that. Also, this task list BOF would allow us to target a remote system. So say you were about to attempt lateral movement, but you wanted to see, like, is an admin logged in, or other things about the current state of what's running on that box. Assuming you had the permissions to be attempting that lateral movement, you would have the permissions needed to do a remote task list. It's worth noting this is operating over WMI to pull this information.
Another area that we also want to check, as I mentioned before, are the services. Again, correlation, one of the things that you may notice with some of the processes that are running, they may not fit with the services that we're seeing. This is going to be important even in our initial stages if we want to check if we have landed in a sandbox, an RE system, or just a detonation system that simply takes a payload, detonates that payload. And all of a sudden we think that we're in the host and actually we're not there. We're in an analysis system, and just looking at the services installed in the machine, we may see products that may raise alarms for us. In addition to identify possible persistence areas for us, we also get the purpose of the machine. All of a sudden, if we are lucky enough to land on a server, we can check, hey, is this server a file server, DNS server, domain controller? If we land in a customer box, we can also check for applications. All of a sudden, we have seen customers that actually run for EDRs. I don't know why, but they run for EDRs on their box. They feel safer that way. So all of a sudden, that means that we have 4 different things to contend to, that one may catch and the others may not. Also, we may see stuff that, hey, this looks very suspicious. Somebody disabled this AV product. They may not be there in that box, but that means that more than likely somebody was there. And then all of a sudden your pen test or your red team engagement becomes an instant response one.
So for this, it's pretty simple. We have a SC enum. We actually have a whole family of SC commands, which you can look at just with help, which are all basically the extensions off of what you would use with sc.exe. But for this one, sc enum, and you get all of your different services, and you can look at, you know, how it's configured. Is it currently running? What are the things it takes if the service crashes? And are there specific startup triggers? So things that would make this service start without you having to issue a service start command.
Another one that we recommend that you check is scheduled tasks. With scheduled tasks, many times this gives us an idea of how the system admins are managing the systems. One of the things that we see a lot is that system administrators are going to put or deploy what are called run once tasks that get deployed via GPO or SCCM to perform actions as system on the different boxes, and they'll simply leave them there. And all of a sudden we have kind of like a list of stuff that is being done on that system. And just by looking at the credentials, sometimes we may see alternate credentials that may be DA in the environment. And Windows has a habit of storing those credentials inside of the credential vault of system. And even if you delete the scheduled task, those credentials are going to stay there. It doesn't clean that out of the credential vault. So that is another avenue for us that we can just check, kind of gauge a bit what are their maturity level. If the maturity level is very high in terms of their security actions, controls, and how they manage stuff, we kind of move a bit slower, a bit more careful. If not, we can probably ramp up our operational tempo. In addition to that, there are security products that actually schedule actions for scanning via scheduled tasks, and we may get time windows that we can operate or do actions on a target system. And in addition to that, we can also check for cohabitation. Hey, is there somebody in this system that shouldn't be there?
So yeah, and I will get to your question in just a second, IPSlub. So for this, we have sctask enum, which does literally what it says on the tin. It enumerates all the scheduled tasks. Specifically, it's going to be outputting them in the XML format. So that allows us to get all of the optional settings that might be on there as well, and just some of the more in-depth information. For this and SC enum, both of them, they're going to overflow the console. So to actually go back and get useful information out of this, you're going to have to log into your team server and then look at the beacon log, which That brings us to the end of this presentation. We already have one question. So a lot of what we've talked about here is when you first get on a box, you don't know exactly what protections are in place. And if you were able to, in your example, get a dropper on a machine, it was able to successfully execute, and you got a callback, that means you've already bypassed whatever defenses were there for that much of the chain of action to occur. Or it's been alerted on and they're going to do a full investigation, in which case it doesn't matter what else you're doing at that point because it's likely going to be detected. So what we're more recommending isn't to just never do any process injection. It's whatever method that you used to initially gain process code execution. So like say it was a VBA macro. If you execute that code such that it's executing within Word, yes, you do risk the user closing it. But if that's something that they're ready to catch, you can do some of this situational awareness, information gathering to make determinations of, would I be safe to process inject? And if so, like, is there a certain method that I should use? So for instance, we've run into the instance where in that exact situation, if you're in Word, there are some EDRs that will detect you if your process injection target happens to be literally any binary out of System32 or SysWow64. But if you simply change it so that you're injecting something out of, say, program files, or program files, then it doesn't care and it doesn't alert on that. So that's more what we're talking about. As far as you take your initial step and then you do the information gathering with some of this to determine what you do for your next step. Does that kind of answer your question?
In addition to that, to add to what Chris mentioned, you can also use this, what we just covered, as part of your payload automation. For example, you can do a quick check for processes or a quick check for services as part of your payload and decide if there's anything that is going to detect process hollowing or process injection. And you can change curse and do another technique. Or if it doesn't see any one of those for the information that you have collected in previous engagements, all of a sudden you go like, hey, there's no protections here. All of a sudden I landed in a box where it's only running Defender and I know that I can inject into this other process and not get detected. I'm injecting there. So you can use this situational awareness not as something that you can do manually always, but also it could be automated and you can have inside of your code a minimal decision tree for taking actions, or you can pull that information, send it back to your C2 and have your C2 run a more extensive decision tree process to decide other actions. Cool. Any other questions? If not, thank you for your time and listening to us share a bit of knowledge.
Yep. And just a reminder, this is round a monthly series. Might go a little further, might go a little shorter in terms of reoccurrence, but we'll see you in the next one.